Hey everybody, it's Jenny from Norman S. Wright. So last week we talked about the chiller, and I talked about the different components of the chiller and how they fit into the refrigeration cycle. So this week let's continue on with chillers and talk about different type of chiller compressors. Let's get started. The majority of chillers used are vapor compression chillers that use mechanical energy in the form of electric motors to drive the compression of the refrigerant. The four types of chiller compressors are reciprocating, centrifugal, screw, and scroll. Chiller compressors are either positive displacement or dynamic compressors. Positive displacement compressors physically compress the vaporized refrigerant into a smaller volume and higher pressure. These deliver a constant volume of gas under a constant speed. Dynamic compressors increase vaporized refrigerant pressure by kinetic energy using a rotating impeller. So let's move this out of the way and look at how these work. Let's start with the reciprocating compressor. Reciprocating compressors are positive displacement compressors that use the reciprocating action of a piston inside a cylinder to compress refrigerant. It looks something like this. You have a motor driving pistons on essentially a crankshaft. So these blue ones are the pistons, and this is rotating. So as this arm rotates, it moves the pistons up and down inside the chambers. So if you have refrigerant coming in through here, as the piston moves up and down, it compresses it and comes out at a higher pressure. So let's do this. The motor drives the pistons, the light blue in this drawing, up and down to compress the green refrigerant that's coming in into a higher pressure, which is the red refrigerant coming out. Let me grab this section and move it down so I can draw a little bit above it. And so up here, you'll have the discharge side of the compressor, and then your high pressure refrigerant would leave through here, and then everything kind of inside this area here is the compressor itself. Reciprocating compressors can be air-cooled or water-cooled. They are being phased out and replaced with newer, more energy-efficient technologies. They have more moving parts, and so they require more maintenance than some of the newer compressors. Let's move this over and look at centrifugal compressors. Centrifugal compressors are dynamic compressors. A centrifugal compressor uses the rotating action of an impeller wheel to exert centrifugal force on a refrigerant inside a round chamber called the volute. The refrigerant is pressurized as it's forced against the sides of the volute. It looks something like this. In the center, we'd have the impeller wheel, and the refrigerant will come in through the center. The centrifugal force forces the refrigerant against the outsides of the volute, increasing its pressure, and then it discharges through the discharge side of the compressor. Centrifugal compressors are good for compressing large volumes of refrigerant to relatively low pressures. Chillers that use centrifugal compressors usually have one or more impeller wheel in series. It's a simple design and has few moving parts. This type of compressor is common for central plants in large buildings. Now let's move this over and look at screw compressors. Screw compressors are positive displacement compressors. They basically have two screws that rotate into each other. There's a single screw or twin screw design. Either way, as the screws rotate, they push the refrigerant further into the compressor and squeeze it into a small space. The refrigerant exits at a high pressure. So if you imagine these two screws rotating towards each other, you could see how it would increase the pressure of a fluid moving through the center of it here. That's basically what we're looking at. So let's draw this kind of in a side view. And this is one of the screws, and then this is the other screw. And they are rotating into each other. As the refrigerant comes in on this end, and as the screws rotate and push the refrigerant further into the compressor, it's squeezed into the smaller space, and it exits on the other end at a high pressure. So let's write this one out again because it's a little bit hard to tell what's going on in the drawing. The refrigerant that comes in, green in the drawing, gets squeezed through the compressor into tighter spaces, and it comes out the other end as a high pressure, in the drawing red, refrigerant. Let's move this over and look at scroll compressors. Scroll compressors are positive displacement compressors. They're made up of two offset spiral discs that are nested together. One disc is stationary and the other one rotates. So let's draw this. So I'm going to fill this in, and then we'll take out a section and make that the first spiral disc, and then draw a second spiral disc in it. And so this disc moves around kind of like this inside the other spiral disc opening. And that's how the compressor works. So the refrigerant will come in on the end like this and get compressed by the spiral disc as it moves towards the center, and then the discharge will come out of the center at a higher pressure. Let's write this in. The refrigerant in green is compressed into the tighter space by the spiral movement, which increases its pressure. So let's bring all this back on screen. And I know it would be easier if I had actual cutaways of compressors. I will try to find some video or take some video if I can to show what these look like in action, but hopefully this gives you an idea of the different types of compressors and a basic idea of how they work. Don't forget to subscribe to our YouTube channel. Thanks for watching.